Hello everyone. Hope you are doing very well. Today, as you all know, that we are going to cover the theory part 2 of haloalkanes and haloarenes. Right? We have already covered some introduction and the classification part in our first chapter. So let's begin in our first part. Let's begin our today's topic, that is NCRT chapter 6, haloalkanes and haloarenes, theory part 2, in which we are primarily considering or primarily covering the NCRT section 6.2. This is disclaimer. The objective, so today's lecture objective, after attending this lecture, you will be able to name the haloalkanes and haloarenes according to the IUPAC system. Okay, so according to the IUPAC system, how you name or what is the nomenclature of haloalkanes and haloarenes, that we are going to learn today. The topics that we are going to cover according to the NCRT, they are first of all the section 6.2 nomenclature. Then we will also cover an example, NCRT example 6.1, and then we will see an exemplar question, that is 19. Let's start with the nomenclature 6.2, right? So let's first of all see the nomenclature for monohalogen molecules. We have covered about the monohalogen molecules, right? Monohalogen means, mono means single, one. So any molecule which is having one halogen in it, any structure which is having one structure in it, that is the monohalogen molecule. So let's see its nomenclature, starting with common names. Monohaloalkanes are known as alkyl halides. So we can also call the monohaloalkanes are as alkyl halides. Alkyl means the alkyl group, the R group, okay, like methyl group, ethyl group, okay. Halide means halogen, the group 17 elements, right? Fluorine, chlorine, bromine and iodine. So monohalogen alkanes, you can also call it as alkyl halide. Alkyl halides are named by naming the alkyl group followed by the name of halide. Okay, so how you name the alkyl halides? It can be named by first of all naming the alkyl group, whatever alkyl group is present, methyl, ethyl, and then you can write the name of halide it is attaching with. For example, methyl chloride and N-propyl bromide. Okay, so first of all we are writing the name of alkyl group, methyl, and then following by the name of halide, halogen, that is chloride. So methyl chloride. Similarly, N-propyl bromide. What N represents? N represents a single chain of propyl alkyl group having a single bond between each carbon, and bromide followed by the name of the halide, that is halogen is here is bromine, right? So the name will be N-propyl bromide. Let's see the IUPAC system. So according to the IUPAC system, alkyl halides are named as halo substituted hydrocarbons. Either one or more hydrocarbon is replaced by halogen atom. Okay, so alkyl halides are named as halo substituted carbon, hydrocarbon. So the name of the hydrocarbon, and it is halo substituted. That means halogen is present in it. So alkyl halides are named on the basis of or as the halo substituted hydrocarbons, where one or more hydrocarbon is replaced by the halogen atom. That's why substitution happens, right? Halogen is treated as a substituent, and prefix we use for it is fluoro, chloro, bromo and iodo. Okay, so halogen is treated as a substituent. That means in that hydrocarbon, halogen is present as a substituent group, and after the removal of one or more hydrocarbon, and it is present in the name as a prefix. Like for fluorine we use fluoro, for chlorine we use chloro, for bromine we use bromo, and for iodine we use iodo. The longest carbon chain is selected as the parent alkane. Okay, so in the IUPAC system, first of all, we have to select the longest carbon chain existing in our structure, and that we are going to treat as parent alkane. Okay, parent alkane. Numbering is done to give the halogen substituent the lowest possible number. Now, when you have selected the parent alkane, which can be which is longest, okay, so you have to first of all select the longest carbon chain, and when you have selected it, you have to start numbering. Okay, numbering is done in this way that the substituent, that is halogen in our structure, halogen should have a lowest possible number. Okay, so you have to name that parent alkane in such way that the carbon at which halogen is present, the substituted halogen, it should have a lowest possible number. Okay, alphabetical order is followed for multiple different substituents. Now if you have different multiple substituents, like if you have more than one kind of halogens present in your structure, then you have to follow the alphabetical order. For example, you have a structure of some alkane and alkyl halide where there are two halides, halogens. First is fluoro, then is chloro. Okay, now how can you write the name of that? So you have to consider both the halogens, right? So while writing the name of the substituents, fluoro and chloro, you have to follow the alphabetical order. So chloro will come first in the name, then fluoro will come. For example, you have given this structure of 2-bromo, 3-fluoro, pentane. So you can see pentane means 5 carbon are present in our longest carbon chain. So first of all, you have to select the longest carbon chain, which we are selected here from C1 to C5, right? And then you have done the numbering in such way that bromine and fluorine carbon will get the lowest possible number. So let's say you are starting the numbering is already given. Okay, let's start from the reverse. Let's start from the fifth carbon. Let's say we have given the C5 as C1. Okay, so if you put 1 here, 2 here, 3 here, 4 here, and then 5 here, so the halogens are substituted at a particular carbon, and those carbon will get 3 and 4 number, right? Now 3 and 4. Okay, now if you do the numbering like this, which is given already, 1 2 3 4 5. Okay, now what is happening, the halogen is connected to these carbon which are having the number 2 and 3. So 2 and 3 is lesser compared to 3 and 4 number, right? So we put or we consider that numbering of the longest carbon parent alkane in which our substituted or halogen substituent carbon will get the lowest possible number. So we'll consider this from left to right numbering in our longest carbon chain selected as the correct way, right? So then we get the name. We have to follow the alphabetical order here because two halogens are present. So bromo and fluoro. So bromo will come first. So we write at the second position the bromine is present. So 2-bromo. At the third position, at the third carbon, the fluorine is substituted. So 3-fluoro, 2-bromo, 3-fluoro, and then the name of the alkyl group, that is pentane, alkane group. Okay, so this is the name of this structure given, 2-bromo, 3-fluoro, pentane. So let's see the IUPAC name of halogenated compounds. So you can see we have different compounds given here. First of all, let's consider the first one, CH3, CH2, CH2Br. Br means bromine. So this is a halogenated compound. Halogen is present in it. The common name of this will be N-propyl bromide. Okay, N-alkyl halide, N-propyl bromide, right? But for the IUPAC name, what you have to do, you have to select the longest chain possible, and this is like simple single chain, right? Because at the last carbon, or you can consider first carbon at which the halogen is substituted, so it is a single chain. So the numbering is starting from the lowest possible number that is going to be given to halogen substituent carbon, right? So in the longest possible chain, that is in the CH3, CH2, CH2Br, you have to start the number in such a way that bromine substituted carbon will get the lowest possible number. So that could be 1 only, right? So 1, 2, 3. Because if you start numbering from here at the left hand side, 1, 2, 3, carbon at which the bromine is attached will get the 3 number, which is comparatively larger than 1. So we follow the case where this carbon will get first number, 1 number at which bromine is present. So 1, 2, 3. Okay. Now at first carbon we have bromine. So we write the IUPAC name as 1 bromo and 3 carbons are present. So propane. 1 bromo propane. Ane in the end because we have single bond. We have alkanes in the structure or in the formula, right? If you consider the second one, the common name of this will be isopropyl chloride. Okay, it is CH3, CH, CH3, and at the second carbon, second, why I'm saying second, because if you start from left, if you start from right, anywhere, this the center carbon will come at second position. Okay, so here you can start the numbering from anywhere, and because the chlorine carbon will get 2 number in both the cases. So the common name of this is isopropyl. Basically, the first of all, if the chain of our alkane or is substituted, then you have to put a word here to like signifies that it is substituted at which position. Okay, and then alkyl group name, that is propyl because 3 carbons are present, and then halide group name, that is chloride for chlorine, right? Isopropyl, iso is suggesting that the substitution is happening at the center or at the second position. Okay, iso means at the second position, the second carbon, the substitution is happening. So that's why its common name will be isopropyl chloride. Okay, for the IUPAC name you have to done the numbering. So you have selected the longest carbon chain, which is this, because it is a single chain, and the numbering should be done in this way that chlorine substituted carbon will get the lowest possible number. Here if you done the numbering from left or right, in both the cases the carbon will get the second number. So the name will be 2-chloropropane. Propane because 3 carbons are present, right? Similarly, in the third structure, we have CH3, CH, CH3, CH2, Cl. Okay, so the common name of this is isobutyl chloride. So in this structure, the substitution is happening at the second position, right? Like if you consider from the rule that you have to number the longest possible chain in this way that the halogen substituted carbon will get the lowest possible number, then 1 should be here, right? So 1, 2, 3. At the second position, we have methyl group as a substituted group. So that's why we are writing here isobutyl chloride. Okay, with the chloride, we are not writing any number or so. So this is a isobutyl chloride. Okay. For the IUPAC name of this, we have to do the numbering. So numbering will be 1, 2, 3, right? At the first position, we have chlorine. So 1 chloro. At the second position, we have substituent as methyl. So 1 chloro, 2 methyl, and the rest of the carbon in the longest possible carbon chain is 3. So 1 chloro, 2 methyl propane. Right? Now if we talk about this, you can say arylic halides. The common name for this, when bromine is directly attached with the benzene ring, the common name of this is bromobenzene. And the IUPAC name will also be same, that is bromobenzene. Okay. For the second structure, we have 2 bromines present at different positions. You can say at the first carbon we have bromine, at third carbon we have bromine, right? So the common name of this is meta-dia-bromobenzene. Okay, meta-dia-bromo, that means this position, which is the third position of the benzene, this is classified differently as meta position. Okay, so at the meta position we have 1 bromine, and at the first position we have 1 bromine, right? So we write the common name as meta. M is for meta. Diabromo because we have 2 bromine. Benzene. Diabromo. So you can ask that if one position of bromine is classified as the meta position, the another, how you identify from the name. So name has diabromo, that means 2 bromine will be present. So if the position is not specified in the common name, that means it is going to be present at the first position. Okay. So meta diabromo, and dia means two bromines, one is at meta and one is at first position. So meta diabromo benzene. IUPAC name for this will be, you have to done the numbering in every case. So the numbering is done from you have to start from somewhere, right? So start from the carbon at which the halogen is present to get to give it a lowest possible number. So if you start from here, the one position is at which the bromine is present, then second, then third position bromine is present. So you write 1,3 diabromo benzene. Okay, 1,3 diabromobenzene is the IUPAC name of this structure. Now if you consider the triabromine structure, where three bromines or you can say three halogens are present. So this structure, you can call it as symmetrical triabromobenzene, right? Or you can say sim triabromobenzene. Tria because three bromines are present. This is a common name, you have to learn it. IUPAC name, for IUPAC name you have to done the numbering. You can start from anywhere. So if you start from this carbon, so you have to give it 1, okay? Because the carbon at which the bromine or the halogen is present, you have to give it a lowest possible number. So let's start with 1 with the carbon at which bromine is present. So 1, 2, 3, at 3 there is bromine, 4, 5, at 5 there is bromine, right? So there are total 3 bromines. So how you can write the IUPAC name? 1,3,5 triabromobenzene. Okay. Now let's see this structure, which is CH3, 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 CH2Cl. That means at a single carbon, 3 substituents are methyl groups, 1 substituent is CH2Cl. So how you write the IUPAC name of this? You have to done the numbering, and numbering after selecting the longest chain possible, right? You are selecting this chain, this horizontal chain, as the longest possible chain containing 3 carbons, right? Because if you select in any way, like if you say this is the CH2, then you select this carbon and then you have to move in some direction. So if you move in upper direction, then also 3 carbon will cover in the longest possible chain. If you move in the horizontal direction, then also longest chain possible is with 3 carbons. If you move in the lower direction, then also only 3 carbon will cover in the longest chain possible, right? So you are selecting this horizontal way more which will be more easy to select. So Cl, CH2, C, CH3. This is the longest chain possible. Now you have to done the numbering, and you have to consider the substituted carbon should get lowest possible number. So let's start with 1. Okay, so 1, 2, 3. Okay, at first position we have chlorine. At second position we have 2 substituents, that is methyl group, 2 methyl group. Okay, so the IUPAC name will be, first of all, halogen name and its position. So 1 chloro, 2 dimethyl. Okay, we write the 2 twice to represent that there are 2 substituents. So 1 chloro, 2 dimethyl propane, because in our chain we have 3 carbons. So we write it here propane. Other 2 carbons you have already justified by writing dimethyl. Okay. Now if you see the last structure, this is CH3, CH3, and the second position we have bromine. So this is easy, you can do this. Okay, so you have to select this longest chain possible. The second number will come at the carbon at which bromine is present, so the name will be 2-bromo-propane. Okay, or you can also say its common name will be 2-isopropyl bromide, right? So these are the name of the halogenated compounds given, common and the IUPAC name. Let's move further towards the nomenclature for diahalogen molecules. So for the haloarenes means when the halogen is connected with the aromatic ring. The prefixes O, which is for ortho, M, which is for meta, and P, that is for para, are used in the common names for the haloarenes. Okay, and IUPAC uses numbering 1, 2, 1, 3 and 1, 4 respectively for these. Like for ortho, we use the numbering as 1, 2 because at first position there is some halogen, at second position there is some halogen. We are talking about dihalogen molecules. Two halogens will be there, and in the haloarenes, that means when two halogens are connected with the aromatic ring, are bonding with the aromatic ring. So we have prefixes ortho, meta and para, which we are going to use in common names, and the position in the IUPAC name we number it for, like for ortho we use the number 1 and 2. That means at first position there is a halogen, there is second position there is a halogen. Okay, so for ortho in the common name we use the numbering 1 2 in the IUPAC name. For meta we use 1 3, for para we use 1 4. Let's see an example. So we have these examples where we are just changing the positions of the bromine halogen. Okay, so this is a dihalogen molecule where in the case of haloarenes, that means bromine, which is a halogen, is directly attaching to a aromatic ring, that is benzene. So when bromine are present at first and the second position, you can call it as 1,2 diabromobenzene. Okay, because at first and second position you have to put the lowest number possible at the carbon at which bromine is present. So 1,2 diabromobenzene, or the common name will be orthobromobenzene. Okay, or orthodiabromobenzene. The B is where the halogen is present at first carbon and the third carbon, 1 2 3. Okay, so the name will be 1,3 diabromobenzene. Okay, 1,3 diabromobenzene, the IUPAC name. Similarly, the C structure where the bromine is present at first position and then 2 3 4, and bromine is present at fourth position, the opposites. Okay, so we write the IUPAC name for this as 1,4 diabromobenzene. Okay, so this is how you have to name in the IUPAC system for haloarenes, which are dihalogen molecules. Dihaloalkanes having same type of halogen atoms are named as alkylidene and alkylene dihalides. Okay, so dihaloalkanes, that means alkanes having two halogens connected to them. They have same type of halogen atoms. Okay, so we are considering the case where same type of halogen atom is present in two number. They are named as alkylidene and alkylene dihalides. Dihalo compounds are further classified on first is gem dihalides. Okay, so you can also call it as alkylidene dihalide. Okay, in which halogen atoms is present on the same carbon. Two halogen atoms present on the same carbon, then we called it as, it is a dihalo compound, right? Because in the structure two halogen is present, but in this case on the same carbon we have two halogens, so this is considered as, or this is classified as gem dihalides or geminal dihalides. Then comes the vis dihalides, or you can say vicinal dihalides. Okay, in these halogen atoms are connected to the adjacent carbon atoms in the structure. Okay, so halogen atoms when present on the adjacent carbon atoms, then we consider and we call it as vicinal dihalides. If you see the example, the first example includes the gem dihalide where CH3CHCl2, that means at first carbon we have two chlorines present, right? So two halogens present on the same carbon, so it is the common name of it will be ethylidene chloride. Okay, ethylidene chloride or geminal dihalide. This is the geminal dihalide, right? IUPAC name for this will be, at the first position we have two chlorines, so we write 1,1 diachloro, and we have total two carbons, so 1,1 diachloroethane. For the second structure we have CH2Cl, CH2Cl, right? So the common name will be ethylene diachloride, not ethylidene. Ethylidene is for the compound which is gem dihalide, where at the same carbon two chlorine or two halogens are present. But when the halogens, that is two halogens, are present on adjacent carbon, adjacent means like side by side. Okay, then the common name will be ethylene, or you can say alkylene, whatever alkyl group is present, diachloride. Okay, and this is a vicinal dihalide, and the IUPAC name of this will be 1,2-diachloroethane, because at first position and the second position carbon both have chlorine. So 1,2-diachloroethane. Let's see the common examples of halo compounds. So we have this table given where 3 columns are there. First of all, the structure, their common name, and their IUPAC name. So structures are CH3, CH2, CH, Cl, CH3. Its common name is secondary butyl chloride, and the IUPAC name for this is 2-chlorobutane. Okay, so you can see the structure we have at the second position. If you've done the numbering, at the second position you have chlorine, so it is a secondary butyl chloride. And butyl, that means 4 carbons are there. Chloride, because chlorine is the halogen that is present at the second position. IUPAC name will be 2-chlorobutane. Okay, 2-chlorobutane. And also the chlorine present at the carbon, which carbon is attached with 2 other carbons. So that's why we are calling, or we are writing here as a prefix as secondary, SEC. Okay, secondary butyl chloride. Then we have structure CH3 whole thrice CCH2Br. This is a neopentyl bromide. Okay, this is a neopentyl bromide. We have bromine present at the carbon. Which carbon? Like here the structure is having 3 substituents, right? So this is a neopentyl bromide, and IUPAC name, if you want to write, it will be 1-bromo, because at the first position we have bromine, and 1-bromo 2,2-dimethyl, because at the second position we have 3 substituents of methyl. Okay, one will contain in this primary chain, in parent chain, the other 2 will be acting as a substituents. So we are writing name as 1-bromo. At the first carbon we have bromine, at the second carbon we have 2 substituents as methyl, and the third substituents as methyl is containing in our parent chain, the longest possible parent chain. Okay, so we count its number in this propane name, because first carbon is this, second carbon is this, third carbon will be the from one of the methyl. So IUPAC name will be 1-bromo 2,2-dimethyl propane. Similarly, the next structure CH3 whole thrice CBr. This is a tert-butyl bromide, I mean tertiary butyl bromide. Bromide is present at the carbon which is connecting with 3 other carbons. So this is a tertiary butyl bromide. We have 4 carbons present in this structure. If you want to write the IUPAC name, you have to select the longest possible chain, and then numbering will be done, after which the IUPAC name will be 2-bromo 2-methyl propane, because at the second position we have 1 bromine, at the second position we have 1 methyl, and we have propane other than that. Okay, after selecting the parent chain of the 3 carbons, we said that 1 methyl will be the substituent 1 and the other 2 are in our chain. So it will be 2-bromo 2-methyl propane. Next structure is CH2 double bond CHCl. The common name for this is vinyl chloride. Remember, we have studied about the vinylic compounds where halogen is connected to directly sp2 hybridized carbon, or one of the atom of carbon double bond carbon, right? So here the same thing is happening. Chlorine is attaching with this carbon which is in double bond with CH2. So we are stating its common name as vinyl chloride, and its IUPAC name will be chloroethene. Next is CH2 double bond CH2Br. This is a allyl bromide. Allylic compounds where bromine, or you can say halogen, is present, or it's is bonding with the sp3 hybridized carbon, but that carbon is attaching with the sp2 hybridized carbon. The same thing is happening here, so we are calling its common name as allyl bromide, and its IUPAC name will be 3-bromo propene. 3-bromo propene, because at the third position we have double bond, right? No, we have at the third position we have bromine, and we are here considering like double bond giving lowest possible number as more important, because this is the fact. Okay, you have to give the lowest possible number to the double bond if you have halogen present still. So you are doing it, and you are starting your numbering from the very left hand side from in this compound CH2 double bond CH CH2 Br. So 1 2 3, so 3 bromo and propene. Okay, next is O Cl C6H4 CH3. C6H4 is for aromatic ring. CH3, that means one of the substituent at the aromatic ring is methyl at the first position, and chlorine at the ortho position, right? So we call its common name as orthochlorotoluene, and IUPAC name as 1-chloro 2-methyl benzene or 2-chlorotoluene. Okay. Next structure is C6H4CH2Cl. The common name of it is benzyl chloride, and the IUPAC name of this is chlorophenyl methane. Okay, because we have C6H4, that is the aromatic ring, which is substitute, and the substituent of it is CH2Cl. Okay, so the IUPAC name will be chlorophenyl methane, and the common name is benzyl chloride. Next structure is CH2Cl2. The common name is methylene chloride. IUPAC name is diachloromethane. Remember, we have just studied diahalo compounds. So this is the diahalo compound CH2Cl2, where 2 chlorine is present at the same carbon. So we are writing its name as alkylene chloride. Okay, methylene chloride, and the IUPAC name will be diachloromethane. Then comes CHCl3, that is chloroform, whose IUPAC name is triachloromethane. Okay, then our CHBr3, whose common name is bromoform, and the IUPAC name is triabromomethane. Then comes CCl4. The common name of this is carbon tetrachloride, because we have 4 chlorine connected with the carbon. So carbon tetrachloride, and the IUPAC name will be tetrachloromethane, because only one carbon is present. Then CH3, CH2, CH2F. The common name of it will be N-propyl fluoride, and the IUPAC name will be 1-fluoropropane, because at first position we have fluorine, and then we have 3 carbons in our chain, so 1-fluoropropane. Okay, so this is the table representing some common examples of halo compounds according to the rules and the classifications we have studied until now regarding the halo compounds. Let's solve an example. Example 6.1. Draw the structures of all the 8 structural isomers that have the molecular formula C5H11 bromine. Name each isomer according to the IUPAC system and classify them as primary, secondary or tertiary bromide. Remember? So you have 2 questions in it. Okay, first is that you have to draw the structure of 8 structural isomer having this molecular formula C5H11 bromine. You know the structural isomers, right? Where the molecular formula is same but the structure is different by just interchanging some substituent from any carbon to any carbon. Okay, so you have to draw the 8 structural isomer of this formula, and you have to name the each isomer according to IUPAC system and classify them as primary, secondary or tertiary bromide. So it's very easy. Try to do that, and you have some time. After that, we will see the correct answer and the correct way we can solve it. Okay, let's see. So for this example, we have already given the formula, right? So let's first see the rules for IUPAC nomenclature. How can you name a particular compound or a particular structure according to the IUPAC? So organic compounds IUPAC name consists of three main parts, which is word root, suffix and prefix. Okay, so you have to consider that first of all, whatever the organic compound you have, its IUPAC name will contain three main parts. So first of all is word root, then the suffix you have to add, and then the prefix you have to add. Let's see in this table about the each component. So if you are having a component that is word root, what it tells you, that you have to know the length of the main carbon chain. You have to first of all know the main, or you can say parent chain length. Okay, that how many carbons will going to be contained in that. Examples and purpose, like meth you are going to use for 1 carbon, eth 2 carbon, prop 3 carbon, etc. So the whole name will change after considering the number of carbons, right? Next is primary suffix. What does it mean? What it tells you? The type of carbon-carbon bonds in the main chain. Okay, like either the carbon-carbon bond is single bond, double bond, or triple bond. Okay, so what type of carbon-carbon bond is present in the main chain, that you have to also consider in the organic compound IUPAC name. For example, ane we use for all the single bond. If all the single bonds are present in our main chain, parent chain, then we use ane as a primary suffix. If we have at least one double bond or unsaturated hydrocarbon, then we use the primary suffix as ene. Similarly, we use the primary suffix as ine when at least one triple bond is present in our parent chain or it is an unsaturated hydrocarbon. Okay. Next component is secondary suffix. Secondary suffix means what it tells you, the main functional group present in the molecule. The main functional group. Okay. Either it is a halogen or any functional group that you have to identify, which is present in our parent chain or in our molecule. For example, we use OL, that is ol for alcohol functional group. We use Al, that is aldehyde, as a secondary suffix. Al as a secondary suffix for aldehyde functional group, etc. Then the component is primary prefix. What does it tell you? It tell you, or it indicates if compound is cyclic or not. Okay, for example, we use the cyclo for the cyclic compounds. If it is a cyclic compound, that means we have a cyclic structure. Okay, then we use cyclo while naming for the cyclic compounds. Next component is secondary prefix. What it tells you, the substituent groups, branches, or any other atom that is attached to the main chain. Okay, so to the main chain, that means to the parent chain, what are the substituent groups, what are the branches of other atoms that are present. Either it is any functional group, either it is an alkyl group. Okay, for example, we use methyl for CH3, chloro for chlorine, right, bromo for bromine if it is present as a substituent group in the parent chain. Okay, so these are the factors, or these are the main parts which you have to consider while naming of a organic compound according to IUPAC. The arrangement of component for IUPAC nomenclature. How can you do so? First of all, you have to arrange the secondary prefix, then comes the primary prefix, then the word root will come, then the primary suffix, and then the secondary suffix. This is the arrangement of the components for IUPAC nomenclature. Now, we discuss all the 8 isomers one by one. First isomer of having this formula is CH3, CH2, 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 Br. Okay, that means we have 5 carbon, 11 hydrogen, and 1 bromine. So we place the bromine at first carbon, let's say. So this is the first isomer. So if you number the parent chain will, there is only one chain, so it will be parent chain, right? So when you do the numbering, the carbon at which bromine is present should get lowest possible number. So let's say it is 1. 1, 2, 3, 4, 5. So name will consist of the IUPAC name of this compound will be 1-bromopentane, because at first position we have bromine, and then we write the name of our alkane, that is pentane. So it is a primary bromide because the bromine is binding with the carbon which is binding with one other carbon. So it is a primary bromide. Second isomer is, you just have to change the position of the halogen. So CH3, CH2, CH2, CH, Br, CH3. That means here from the first we have put the bromine at the second carbon. So numbering will be done in this way, where the bromine at the carbon at which bromine is present should get a lowest possible number, which will be 2. 1, 2, 3, 4, 5. So IUPAC name of this compound will be 2-bromopentane. 2-bromopentane, and it is a secondary bromide because bromine is attaching or bromine is binding with the carbon which is binding to another 2 carbons. So it is a secondary bromide. Then the third isomer, CH3, CH2, CH, Br, CH2, CH3. Here the bromine position change. So numbering should be done from anywhere you do the numbering, from left or right. This carbon having bromine will get 3 number. Okay. So 1, 2, 3, 4, 5. And so the IUPAC name of this compound is 3-bromopentane, and it is a secondary bromide. Fourth isomer is CH3 whole twice, CH, CH2, CH2, Br. If you draw the structure, it will be CH3, CH. At this carbon we have substituent methyl group, then CH2, CH2, Br. So we write the IUPAC name of this compound as 1-bromo, 3-methyl, because at third carbon we have methyl, 1-bromo, 3-methyl, butane, and it is a primary bromide because bromine is present at primary carbon. Now let's see the fifth isomer, CH3 whole twice, CH, CH, Br, CH3. The structure, CH3, CH, CH3, CH, Br, CH3. So the numbering is done, right? At the second carbon, the lowest possible carbon, we have bromine, and at our third carbon we have methyl as a substituent. So IUPAC name of this compound is 2-bromo, 3-methyl butane. At second carbon bromine, at third carbon methyl. So 2-bromo, 3-methyl butane, and it is a secondary bromide because bromine is present at carbon which is attaching or which is binding with 2 other carbons. Then the sixth isomer, that is CH3 whole twice, C, Br, CH2, CH3. The structure will be this, that is CH3, C, CH3, Br, CH2, CH3. And when you've done the numbering, you have to consider to give the smallest number to the carbon at which the bromine is present. So it is giving as 2. 1, 2, 3, 4. So IUPAC name of this compound will be 2-bromo, 2-methyl butane. We have parent chain of 4 carbons. So 2-bromo, 2-methyl butane, and it is a tertiary bromide because bromine is attaching with tertiary carbon, the carbon which is attaching with 3 other carbons. Now let's see the seventh isomer, that is CH3, CH2, CH3, CH, CH2, Br. The structure of it is CH3, CH2, CH, at which CH3 is present, then CH2, Br. When you done the numbering, the lowest number will be at this carbon at which bromine is present, and then 1, 2, 3, 4. The IUPAC name of this compound is 1-bromo, 2-methyl butane because 4 carbons are there in parent chain. 1-bromo, 2-methyl butane, and it is a primary bromide. The last isomer, 8th isomer, is CH3 whole thrice, C, CH2, Br. The structure of it is this, that is CH3, C, CH3, CH3, CH2, Br. The carbon at which bromine is present should get the lowest possible number, so 1, and then 2, and then 3. The IUPAC name of this compound is 1-bromo, 2,2-dimethyl, because we have at the second position 2-methyl as a substituents. So 1-bromo 2,2-dimethyl propane, because 3 carbons are present in our parent chain, and it is a primary bromide. Let's solve an NCERT example question number 19. Question is, what should be the correct IUPAC name for diethyl bromomethane? So we have given the name already, which you can say a common name, but you have to tell the correct IUPAC name for this. Options are 1-bromo 1,1-diethyl methane, 3-bromopentane, 1-bromo 1-ethyl propane, or 1-bromopentane. You have given some time. Try to solve this question and then we will see the correct answer. Okay, let's see. So for this question, the correct answer is option B, that is 3-bromopentane. So structure of diethyl bromomethane is given below, which is this. Okay, CH3, CH2, CHBr, CH2, CH3. If you've done the numbering, this carbon at which bromine is present should get the lowest possible number. And if you start the number from right or the left, this carbon will always get 3 number because it is in middle, right? So this is the numbering done. Now you can write the IUPAC name. So IUPAC name for this is 3-bromo, because at third position we have bromine. Pentane, in the parent chain we have 5 carbon, 3-bromopentane. Okay. So from diethyl bromomethane we have this structure, and then from this structure the IUPAC name is 3-bromopentane. Hence the correct answer is option B. Okay, let's see the summary. First of all, the IUPAC nomenclature. We have seen where alkyl halides are named as halo-substituted hydrocarbons, and then longest carbon chain is selected as parent alkane. Then halogen is treated as a substituent. Numbering is done to give the halogen substituent the lowest possible number. Components for IUPAC nomenclature and the arrangement of the components we have seen, which is secondary prefix will come first, then primary prefix, then word root, then primary suffix, and then secondary suffix. And for the dihalogen derivatives, we have seen that the numbers 1, 2, 1, 3, 1, 4 are used for IUPAC nomenclature. And dihalogen compounds are further classified into 2 types. The gem dihalides, where halogen atoms are present on the same carbon. For example, CH3CHCl2. And the second classified dihalogen compound is vicinal dihalides, where halogen atoms are present on adjacent carbon or different carbons. For example, ClCH2, CH2Cl. Okay, so this is the summary that these are the topics, major topics that we have covered today. Okay, thank you. That's all for today's chemistry session. Thank you.